Okay, welcome to this video. So again, on the last video, just as a quick introduction to you, I talked about some things about how we might have to set up and change our bases. But again, remember the key is doing this is that the bases must be the same in order to add or divide. So let's go ahead and just get started on some problems off of this worksheet. And again, I'm going to run through some of the odds for you. So this first one is 4 to the 2x plus 3 equals 1. Okay? So on the last video I told you, remember, if anything equals 1, then we know the rule is that anything to the 0 power is 1. So in this case, since my base is 4 on the left, I could say that this was 4 to the 0. Okay? Now this is an equation. This isn't quite what we were doing earlier. But again, guys, if the bases are the same, okay, here's the quick rule. If the bases are the same, the powers must be the same. And that's where our equation comes from. 2x plus 3 equals 0. Again, the bases must be the same, okay? Bases must be the same. Okay? And then we'll put then exponents are equal. And that's where the equation comes from. Okay? So from here you can handle it. You're just going to go ahead and minus the 3 over 2x equals a negative 3. Divide off. And voila. There's your answer. Now we can do a quick check roll. Okay, so let's do a quick check. So 4 to the negative 3 halves, and that was times 2. Okay, going back up to my problem, plus 3. Well, that would be equal to, I'm not going to put that there. Let's not do that. So this is 4, and when I multiply here, the 2's are going to cancel. I'm going to get a negative 3 left, plus 3, which is 4 to the 0, which is 1, which is what my original problem was equal to. Therefore, it checks. Okay? So, there's one good example. Let's do another one. 3 to the 1 minus 2x equals 243. Okay? So again, we want the bases the same. So basically, we're going to have a base of 3. Now, if we can't make the bases the same, that's a whole nother ballpark, okay? That's a whole nother lesson. So on today's lesson, you should be able to make all the bases the same. So 243 is 3 to the what power? So basically, that's what you're going to ask yourself. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So that is 5. Okay? Bases are the same. Therefore, my powers are the same. Okay? There's my equation. We're going to go ahead and solve. Again, I'm not spending tons of time on the solving bit of it. That should be at this point, a piece of cake. Okay, go back in and check your problem. And really all I need to check on this is we're checking that that's equal 5. So 1 minus 2 times a negative 2. That would be negative 2 and negative 2 is positive 4. That is 5. Okay, that does work. Okay, let's see. I think that was actually number 3, not number 5. Yes, that was 3. Or not number 2. Okay? Number 5, very similar to number 1. If you want to just put a note out to the side, look at number 1. Okay? Number 7. Now, number 7 is actually easier than the earlier ones. Because when you look at this, guys, the bases are already the same. So I'm not actually needing to do anything but set my powers equal or to each other, okay? And you should be able to handle it from there. I'm not going to work them all the way out. You can handle that piece of it. Okay, number 9. and you might put out to the side. Leave yourself room. Finish. Okay? And again, you also need to skip back and do number 5. Okay? Number 9. Now, number 9 is going to take a little bit of work. Not much, but it does definitely take an extra step. Okay. Now, let's look back at the ones we did. And each one of these, we had just a single, let me change colors here. I'll do pink. If you notice here, I had 1 equal to 1. 1 equal to 1. Okay? All of those. 1 equal to 1. Okay? When I get down to this one, I now don't have 1, I have 2. Okay? So what do you think I need to do to those 2? Well, hopefully you said, we need to put these 2 together so that we have a single 1. And that is the truth. Guys, you can only do this piece when you have a base to an exponent equal to a base to an exponent. If you have multiple bases, that's not going to work. So in this case, we need to go ahead and put these 2 together. And we can because it's a multiplication. And we know if we multiply, we add the powers. Right? So I'm going to just go in there and add my powers. 3n minus m. Guys, this is not going to give you a number when you add those powers. Okay? It's still going to give you some variables, and that's okay. 6 to the negative 2m. Okay? Now our bases are the same. Powers are equal to each other. So 3n minus m equals a negative 2m. I wonder if I wrote that wrong. Let me just double check me. Oh, I did. That was an m. That was my bad. Okay, so that's an m. That's okay. We'll just put an m there instead of an n. Okay? So we're going to be able to combine some terms here. So on this side I have 2m equals a negative 2m. Guys, do not, when you see this, divide. Okay? You're going to need to combine like terms. That means move that over. Okay? So I get 4m equals 0. Now go ahead and divide that 4 off, and m is 0. Okay? Now let's go up here and let's check to see if this works. It says m is 0. So if I have 6, and then I have 3 times 0, times 6 to the negative 0, will it equal 6 to the negative 2 times 0? Well, 3 times 0 is 0, so that would be 6 to the 0. And it doesn't matter whether it's negative, we don't have a negative 0. And then this would be 6 times a negative 2 times 0 would be 0. Well, anything to the 0 power is 1, and 1 times 1 is 1. It does check, okay? Guys, if you had tried to divide by 2 or negative 2, everything's going to cancel. You're going to end up with a no solution, okay? So, a couple of things there. If you have variables on both sides like that, you move them all to one side, set it equal to 0, and go from there. Okay, let's try one more, maybe. Number 11. So 10, whoops, what in the world? Here we go. So 10 to the negative 3x times 10 to the x equals 1/10. Now, I showed you an example of this earlier on there. So these are bases of 10. This is 1/10. So anytime you have the fraction and the others are whole numbers or vice versa, the easiest thing to do is change this to a -1 because that means reciprocal. Okay? These two, since they're on the same side, they're multiplied together. Remember, we add the exponents. So a negative 3x plus x, I'll go ahead and write that there. Okay, So this is 10 to the negative 2x equals 10 to the negative 1. Okay, I'll put this out there. Remember reciprocal. Okay, now our bases are the same. Therefore, our powers must be the same. Okay, go ahead and finish that out. Okay, and again, you could go through and check 10 to the negative 3 times the negative 1/2 times 10 to the negative 1/2. So this would be 10 to the 3/2 times 10 to the negative 1/2. So 3/2 minus 1/2 would be 2/2, which is 1. And something's not working out right. So what did I do wrong? Because it's supposed to be negative 1. Did we lose a sign? Negative 2, negative 2. I did, right there. No, but did anybody catch that? Right there's a negative 1. I dropped it. My bad. Okay, but that's why I checked myself, see? So that was actually a positive 1/2. Now let's go back to my check. Let's take off that. Let's go back and put those on there. Okay, I'm going to start all over that way we don't confuse each other. Okay, so hopefully you saw what I did. Right here, I dropped that negative to here. So if you're paying attention, get that negative on there. That makes that a 1/2. So now I'm going to do my check. So see, there's a purpose for a check, because even me in my hurry makes mistakes. So negative 3 times 1/2 is a negative 3/2. There we go. Now this is a negative 2 over 2, 10 to the negative 1, which is 1/10. That checks now with what I need it to be. See, if I hadn't done my check, I would not have caught that I messed up. Okay, so I'm going to stop this video. I will probably try to do one more just to give you some of the harder ones. But this should get you going. So if you actually want to work, go back in and go ahead and do your evens and the ones we skipped until you feel like you need to watch the next video, which will pick up on what where we have to chart changing the base. Okay, so good luck on these. Again, this should get you through about 14.